More people than ever are living in cities. While only 10% of the world's population did so at the start of the 20th century, the number has grown to 50% today. By the end of this century, humans will be a predominantly urban species. As our cities grow, so do the challenges. Space is becoming scarce, and social tensions, traffic, noise, and pollution are all on the rise. At the same time, cities offer many opportunities, such as more efficient use of resources, energy, and infrastructure. After remaining a relatively small specialty field for decades, sustainable building today holds the technological key to the future. Austrian researchers are among the pioneers in the field. The Viennese architects Talik and Jafar Chalabi have won an international competition to build the most modern, sustainable building ever attempted in the United Arab Emirates.
Used together with the structural engineer.
Die Emirate sind ein Land, das eigentlich ziemlich viele neue Ideen aufnehmen.
The Emirates are very open to new ideas. They literally hunger for them. They found our building design very refreshing, and made in Austria is something they equate with superior quality.
Als eine gute Qualität, als was Novum empfunden.
Sustainable building is a well-established tradition in Austria, but Abu Dhabi is just beginning to recognize its importance for the future.
Das Thema der Nachhaltigkeit in den Emiraten ist zusammenhängend mit ihren
In the Emirates, the issue of sustainability is linked to the country's poor reputation for having a large carbon footprint. We remember seeing billboards on the streets that said, "We have the largest footprint," so it's not something they're very proud of.
Das ist nicht eine Sache, auf die sie eigentlich stolz sind.
The United Arab Emirates is one of the 10 richest oil countries in the world. Where small villages stood a mere 50 years ago, booming metropolises now rise. Within a single generation, the Bedouins and pearl divers of yesterday have become business people and bankers. Of the 8 million people who live here, only 1 million were born in the Emirates. They are well taken care of, paying no taxes and receiving many benefits from the government, sometimes even money, cars, or homes. But allegiance, money, and social peace must last after the oil is gone, and steps are already being taken. While Dubai is focusing on tourism and commerce, oil-rich Abu Dhabi is also pursuing renewable energies. In the middle of the desert, near the border with Oman, lies the thriving oasis city of Al Ain. There is almost no rainfall here. Buildings must be cooled and potable water must be treated. Abu Dhabi earns an estimated $300 million a day from oil sales, but Emiratis know that they too must reduce energy consumption for the sake of the country's future. It is in Al Ain, on the grounds of the municipal zoo, where the two Austrian architects are building the flagship project, a museum and research facility in one. The Sheikh Zayed Desert Learning Center, named after the nation's founder. It is intended to show Emiratis and the entire world that sustainable construction is viable even in the desert.
Der Vorplatz ist schön.
The vestibule always stays nice and cool, despite outside temperatures of up to 50 degrees Celsius in summer. This is due to the pleasant draft, even during wind-still conditions.
We
designed the vestibule to have these thermal qualities because we knew there could be a large number of visitors gathered here at times.
Twisting 20 meters up into the sky, the building resembles a walk-in sculpture. Prior to planning the building, the architects studied the topography and culture of the region, as well as the latest international urban development concepts.
Also Stadt der Zukunft, ich beobachte hier zwei Tendenzen. Eine Tendenz ist die
There are two tendencies regarding the cities of the future. The first is the attempt to reshape megacities into lots of small units or little villages. The city as an agglomeration of many compact and manageable areas, with pedestrian zones and short distances to get around. On a larger scale, however, these areas are still interconnected. The other tendency we've noticed is the rise of city marketing, where each city is trying to position itself in the world.
The Chalabi brothers lived in France, Geneva, and Baghdad with their Iraqi parents before moving to Austria. They studied architecture at the Vienna University of Technology and later taught it there as well. In planning the museum, they relied on a number of innovative building technologies that were developed and tested in Austria. But will they work in the desert? The biggest challenge is protecting the museum against the scorching heat. For this reason, a third of the building is set deep below the desert sand. The supply air for the ventilation system is pre-cooled underground using 9 pipes measuring 800 meters in all, as well as a geothermal heat exchanger. The 25 megawatt hours of annual electricity savings derive from a method that has long been applied in Austria, although there it is used to preheat air.
Der österreichische Beitrag seit der 70er Jahre war
Since the 1970s, the Austrian contribution has been extremely important towards making energy savings and sustainability part of the international discourse. The country has definitely been a pioneer, but what is commonplace in Austrian urban development and home building is not necessarily a given elsewhere.
The lighting design and building simulation, the photovoltaic modules, the solar collectors, as well as the building's technical and electrical equipment. All of these components were developed and supplied by Austrian companies. The museum is air-conditioned using solar power and a cooling system from Styria. The boiling hot water from the solar collectors drives the chiller, where cold water is produced and then pumped through a network of pipes in the ceilings and walls.
Die Anlage ist vollautomatisch geregelt.
The system is controlled fully automatically, so no personnel are needed to keep it in operation. An electronic control system runs everything, and monitoring is performed by technicians on site. If a problem does occur, the control system generates a fault indication that is shown on site and also transmitted to Graz. Our engineers investigate the situation, and the problem is either corrected on site, or the indication is acknowledged and the system goes back into normal operation.
The architects have managed to harmoniously balance innovative high-tech solutions and traditional elements in the new building.
Emiratis perceive the building as nearly traditional. We've even heard them say it reminds us of our values and building styles. And that's fitting because we adopted many elements from the traditional architecture and then just put them into a new package.
The museum is still in trial operation, but will open soon. Already, the Desert Learning Center is viewed as a model building for the cities of tomorrow. Sustainable construction used to be a niche topic, but today it is a hot issue everywhere. IRENA, the International Renewable Energy Agency, has its headquarters in Abu Dhabi. Established in 2009, IRENA's mission is to promote renewable energies for the cities of the future.
You have a situation where you have half the world's population living in 2% of the world's land, consuming 75% of its resources. This is a transformative moment of global change that requires a response which is equal to the scale of the change that we are seeing. How are we going to deal with the massive challenges? Energy, production and use of energy, water, both for drinking, for sanitation, food production, distribution, transportation. These are really the kind of challenges that cities are facing today.
But what does a city of tomorrow look like? Especially in the buildings sector, there is an immense potential for savings. Researchers and students are therefore focusing on developing plus energy houses, or buildings that generate more energy than they use over the course of a year. Students at the Vienna University of Technology are designing such a plus energy house. Their intention is to compete at the world's preeminent green building competition, the Solar Decathlon in California.
Participating in this competition is very rewarding for the students. They don't usually get to build a house from start to finish, but now they're involved in all phases: planning, designing, building, furnishing, and even presenting it.
The students are prefabricating their house in a construction hall in Carinthia. They must build it on their own, as prescribed by the strict competition rules. The wooden house is then shipped in containers to Irvine, near Los Angeles, where the Solar Decathlon is held. Now consisting of 48 students, Team Austria has only 9 days to assemble the house. The Solar Decathlon is a competition patterned after the Olympic decathlon, but for futuristic solar homes. Out of 150 university teams from around the world, only 19 have made it to the finals. It is the first time ever that an Austrian team is participating. The Solar Decathlon is the world's preeminent competition for sustainable building, and many Americans wouldn't want to miss it. What they get to see here is definitely futuristic. Modular homes whose components slide apart on rails. Houses that look like tin shacks or haystacks, but which are actually technical masterpieces. In all, 300,000 visitors will take a look at these homes of tomorrow. The U.S. Department of Energy organizes the competition, and only students may participate. During the next several days, the teams will compete in 10 different disciplines. The vision behind the students' work will now be put to a practical test.
And now you can take a look inside.
The Austrian team's house can be used as a standalone home or within compact urban development areas, and it is well received.
People seem to love it, and some even want to move in. Many have asked us if they could buy it. We already had 900 visitors this morning. Everyone was very enthusiastic, which is great, because we put 2 years of hard work into it.
We're ranked somewhere in the middle right now, but there are more contests to come, and we should do quite well in those.
During guided tours of the house, the students impart their knowledge to the attentive visitors.
If you look at places like California, which is one of the most innovative places in the world in terms of technical learning, in terms of governance structures, in terms of how cities are organizing themselves, they are feeling the pressure from energy and water. But then you see in other resource-rich areas where that pressure hasn't yet come to bear, that cities feel they can postpone the change. But it's only a matter of time before it comes. And what my advice to them all would be, that if you defer change today, it's going to be much more expensive and painful further down the road. We need to act today.
The venue for the Solar Decathlon was not chosen by chance. Los Angeles, the horizontal city, is in urgent need of concepts for the future. Sprawling from horizon to horizon, the megacity is drowning in traffic. 18 million people live in the greater LA area, with 20 million expected by 2050. Land, water, and clean air have become scarce. Urban planners know that a turning point is needed, and they are focusing on redensification concepts and creating additional green areas. More and more people are moving to downtown LA and its formerly desolate financial district. Caroline Schmidbauer, an architect who has lived in Los Angeles for more than 20 years, has noticed this trend.
The city's problems are well known and sound like cliches by now. But the traffic problem is definitely acute. There's almost no way to get around other than by car. There's the pollution and the endless urban sprawl. I'm not sure where LA is heading, but there is definitely a lot that needs to be done.
Renowned architectural firms the world over are working on concepts for redensifying our cities. A key goal is to make not only individual buildings, but entire urban quarters into energy producers. The Viennese firm Coop Himmelblau, too, is investigating ways to stop urban sprawl in Los Angeles, while at the same time generating renewable energy.
The idea is to create small hubs that supply their surrounding area with energy. These energy hubs will function like small city power stations. In the lower zones, we use geothermal energy. And in the next layer, we use the sun, especially solar thermal energy, to generate heat. This is possible on the available surfaces of balconies and on south-facing building facades. Then there's the layer where we make use of the sun to generate electricity with photovoltaic cells, for which the buildings are optimally positioned. And in the highest layers, we use the wind to generate electricity because that's where the highest wind speeds are found.
Urban planners from Los Angeles even came to Graz to take a look around. Here, less than 2 kilometers from the city center, 2 new urban quarters are being planned. Hans Schnitzer, the research coordinator, explained the concept to the US experts. In Graz, too, the plan is to redensify the city.
On an international scale, Graz is only a small city, definitely not a megacity. But we also face significant challenges. The current population is around 280,000, with another 3,000 to 4,000 people moving here each year. So by 2050, we can expect the population to grow by 100,000. That's 100,000 more people in need of living space, jobs, and utilities. And if we don't plan ahead, it will also mean around 70,000 more cars, which is simply inconceivable.
Redensification will begin in the heart of the former industrial quarter, which includes a cluster of 19th century buildings, such as those of the old Reininghaus brewery. The buildings are protected under heritage conservation and must be integrated in the redensification plans, including the malt house and spacious cellars that once belonged to the brewery. There are also active industries in the immediate area, but Hans Schnitzer knows that the cities of the future will no longer be divided into industrial and residential zones.
Industries used to pollute and spew smoke, and the air smelled awful. So people moved to the green suburbs, where land was cheaper. Today we want to reverse this trend. People should not have to drive so far, and industries should be so clean and quiet that you can live next to them with a high quality of life.
A good precedent already exists: the Marienhütte steel and rolling mill in the center of Graz. Virtually unnoticed by nearby residents, the mill turns scrap metal into 400,000 tons of steel annually. As an eco-profit enterprise for more than 20 years now, the Marienhütte generates only a small amount of emissions and waste. Materials are recycled and reused, and the mill ultimately benefits all residents of Graz. An innovative energy model was developed to feed waste heat from the steel plant into the district heating network. In the future, the mill will also supply the entire Reininghaus district and its 10,000 homes with heat. The boundaries between city and countryside are becoming increasingly blurred. Green and industrial areas, energy generation, and residential life, work, and recreation will all be integrated within the new cityscapes.
We're trying to create an entirely new city quarter with a main street, a main square, a park, and nearby job opportunities. I find jobs so important because we want people to stop using their cars. They should be able to say, I don't need a car. I can walk to work, walk or ride a bike to take the kids to kindergarten, and walk to go shopping. So we're planning in a very integrated fashion.
Construction work is already underway on Graz's new CO2 neutral and energy self-sufficient urban quarter. The office and shopping complex being built along the main street will shield the residential buildings behind it. The project features many innovative ideas, like the design of the family homes. They are made of multi-level prefabricated wooden modules. The residential and office complex will generate more energy than they use. Together, they will form a surplus energy cluster. In Vienna, too, the city of tomorrow is taking shape. Here, where the subway currently traverses green fields and nurseries, a new densely populated urban quarter will soon be built. From downtown Vienna, it takes only 22 minutes to reach Seestadt Aspern, Vienna's urban lakeside. Within the next 20 years, new homes will be built here for 20,000 people and 15,000 new jobs will be created. The initial phase of construction is finished, and the first Seestadt residents have already moved in. This is the most significant expansion program undertaken by the city of Vienna since the late 19th century, and one of the largest urban development projects in Europe. Completion is scheduled for 2025 at the earliest. Transforming an existing city into a city of tomorrow is indeed a long process. A number of factors must be considered and integrated: innovative building technologies, renewable energies, new mobility concepts, job creation, and adequate industrial and recreational areas. While residents of smart cities will find living with modern technologies to be quite normal, a new generation of researchers is already advancing the concept of sustainable building even further. Competitions like the Solar Decathlon in Irvine demonstrate what is already possible today.
The rules for each event are very strict. They specify exactly how many people may be in the house, as well as the locations where sensors must be located. One in the living room and one in the bedroom. And everything is checked very closely.
The students' futuristic solar homes are tested for 10 days to see if they meet the practical demands of everyday life.
Ready? Go.
Judges inspect the functionality and energy consumption of appliances and PCs, the house's energy balance, and the temperature and humidity inside the rooms. No detail escapes the scrutiny of the officials. The houses are evaluated for innovation, marketability, architecture, and functionality.
The main idea behind the Solar Decathlon is to generate more energy than we use. The photovoltaic system on the roof is rated for 8.6 kilowatts peak. And as you can see, the weather is beautiful, so we're generating a lot of electricity. We have to make sure we don't use more power than the photovoltaic system is generating.
Nighttime in Los Angeles. Commuters are streaming home to the suburbs. But for the Solar Decathlon participants, it is still a long way till knocking off time. Tonight they must host a dinner party that is part of the home entertainment category for testing the house's living comfort. The Austrian students serve their guests, 6 students from a competing team, who will grade the meal and ambiance. The suspense is growing for the students. Which team has built the best house of the future? The soon approaching grand finale will tell. The day has arrived. More than 1,000 students excitedly await the judge's decision.
And now it is my great honor to announce the first place winner of this solar decathlon, the 6th in history in the US, Team Austria from Vienna, Austria.
The first Austrian team ever to participate has managed to come out on top. With a score of 952 points out of a possible 1,000, it has won the preeminent Solar Decathlon Prize. Cities are being redensified and new energy-efficient homes are being built. But what about existing buildings? A pilot project in Vienna may have the answer. The University of Technology's rundown chemistry building is being converted into the world's first plus-energy high-rise.
We're standing on the roof, and above us is the 600 square meter photovoltaic installation. There are also photovoltaic arrays on the facades as one element of the plus energy concept. A second and absolutely essential element is to minimize power consumption. That will be the real challenge, using so little electricity for heating, cooling, computers, etc., that the building will actually generate more energy than it uses.
So wenig Strom verbrauchen, dass wir hier mehr Energie am Standort erzeugen können.
Thick insulation is being installed on the roof and facades, and the 320 kilowatt peak photovoltaic power system will be the largest building integrated unit of its kind in Europe. Even so, there is not enough surface area for the system to supply adequate power for a conventional office building with 700 daily users. The solution? This conventional building must be made into a very special one by reducing its power consumption by an inconceivable 90%. From the ventilation system to computers and even coffee machines, only electrical equipment approved by the research team may be installed. Each device must be analyzed and either optimized or replaced with a more energy-efficient model. Altogether, more than 9,300 components. The renovation of this Vienna University of Technology building is just one City of Tomorrow pilot project out of several hundred that the Technology Ministry is supporting. The program is helping Austrian researchers to expand their knowledge leadership in the field of sustainable building and to apply it internationally. In Al Ain, construction work is almost complete, and the museum will soon open. Ten Austrian companies with a total of around 300 employees helped put up the building in 2 years of actual construction time. The architects give a few final instructions.
This stone should not be water jets, or just needs just a little bit of brushing, that's it.
Austria has an excellent reputation in the Arab countries. Austrian products are held in high esteem, and the label Made in Austria is associated with high quality. Some Emiratis are already referring to the building as Made in Austria because it was built largely by Austrian companies. I think the transfer of know-how functioned quite well.
The offices are now occupied, but museum goers generally visit during the evening hours, so the greatest need for cooling is during a time when the solar air conditioning system is no longer operating. This tricky challenge, too, was solved with technological mastery.
Well, this is very new to the Middle East. Sheikh Zayed Desert Learning Center is the first sustainable building. In the UAE, it's very important because we're trying to change the habits of people of how to understand sustainability a bit more and to apply it in their daily life.
Abu Dhabi is preparing for a future without oil, with an ecologically planned city in the middle of the desert, designed by European architects, supplied with renewable energy. This is Masdar City. an experiment, vision, and flagship project all in one. When completed, it will accommodate 40,000 inhabitants and 50,000 daily commuters. The first part of the city has been built. It stands in defiance of the barren landscape. But behind the outer walls, there unfolds an urban oasis. The Arabic word Masdar means source, and the intention is for Masdar City to gain international importance as a source of knowledge. There are no skyscrapers like in nearby Abu Dhabi. The buildings are 4 stories high. The main streets are 6 meters wide and the side streets 4. This allows the buildings to shade the city's outdoor spaces. It is 10 to 20 degrees cooler here than in Abu Dhabi. Urban heat islands are unable to form, and it is comfortable to spend time outdoors. Plenty of natural light reaches the lower floors, so energy is saved for lighting and cooling alike.
The master plan as a concept is really based on a study of the environment itself in terms of the solar patterns and the way the wind moves through this area. So, for example, the whole orientation of the city is on the northwest axis. And that's because for the majority parts of the year, the air movement of the wind in this area comes from northwesterly direction. So alignments of streets, openings are carefully orientated to capture this wind.
If we can make ecologically sound living possible here in the desert, then it is possible anywhere. This is the credo of the city planners. Research is heavily emphasized, and the university occupies center stage in the ecological city.
We've been able to attract over 2,500 applications from all over the world. We currently have 491 students from 60 countries worldwide. We have graduated over the past 4 graduations that we've had at Masdar Institute, 307 students. All of our students are prepared to be the future leaders, critical thinkers, problem solvers, and innovators in the advanced technology and sustainability fields.
At the Masdar Institute, the research focus is solely on renewable energies and sustainability. A postgraduate student from Carinthia, Austria, is attending the institute. He has lived in Masdar City for 4 months.
The city is an experiment, and a lot of concepts that previously only existed in theory have been implemented here in practice. Sometimes it's a matter of trial and error. Let's try this and see if it works as expected. And that's really very exciting.
The city's innovative personal rapid transit system is what first drew the Austrian students' attention to Masdar City. The vehicles, so-called pods, travel underground to take passengers to their destination. The fully automatic, electrically powered system requires no drivers. But there is a drawback. It is expensive, and only 1 line has been completed. The economic recession is partly to blame, reaching the Emirates in 2010. Further expansion of the city is proceeding slowly. Nevertheless, what has been achieved here in the desert is quite impressive and is already serving as a model for future urban planners.
My students are engineers. I've got mechanical engineers, civil engineers, electrical engineers, and I've brought them here today to expand their knowledge and hope that they will actually understand the concept of a sustainable city. So I think this is a fantastic environment on their doorstep. They're all Emirati students, and I think this is just a fantastic example of engineering at its very best for the future.
Visitors are fascinated by the power-generating systems on the roofs and by the wind tower. The tower catches the wind at a height of 40 meters, then humidifies and cools the air before guiding it to the courtyard. The wind tower is already a city landmark. Particularly among young Emiratis who grew up amidst unimaginable oil wealth and excess, concepts like climate-friendly building and the use of renewable energy are viewed as quite new and progressive ideas. But Austrian students are already a huge step further.
After studying physics and environmental sciences in Graz, I decided to get a master's in sustainable development. I spent a semester in Hiroshima, Japan, where I became interested in sustainable urban planning. Now I'm specializing in water management here in Masdar. It's really quite fitting because Austria values its water resources, and I can apply this knowledge when I get back home.
Masdar City is not the only experimental city, as other futuristic urban planning concepts are being tested around the world, including in Austria. Even if this one may not appear futuristic at all. In idyllic Küstendorf near Salzburg, the new energy future is already underway. Since 2009, the town has been part of a pilot project, and the inhabitants are very eager test persons for jetting around in electric cars. The electricity for their cars and household appliances is self-generated inside the test area. There are 43 photovoltaic systems installed on the rooftops, with a total peak output of 200 kilowatts. Küstendorf is the first smart grid model city in Austria. The project was made possible by a series of technological advancements, of which the smart regulator plays the central role. It controls, like a conductor, the town's orchestra of electricity generating and consuming components to ensure smooth operation of the power network. It is a formidable challenge, as an increasing number of small solar, wind, and water power generating systems must be coordinated with large power plants.
Renewable energies have many advantages. No CO2 emissions, coming from renewable sources. But there's also a disadvantage. Their generation cannot be controlled or planned. We can only use renewable energy when nature lets us. But at the same time, we need to make sure that our customers have a secure supply of power. No one wants to watch TV only when the photovoltaic system is producing electricity. So, balancing the supply and demand for renewable energies is at the core of the smart grid concept.
In Küstendorf, the new smart grid technology is being tested in daily life. The Struber family operates a wholesale business and post office partnership. Every electrical device feeds its data to small metering and management units that control power usage inside the building. The electricity used in the house and to charge the cars is self-generated, and the cars also provide buffer storage for the photovoltaic system. Excess electricity is fed to the grid. The use of intelligent control technologies is not only ecologically prudent, it also helps eliminate the need to build new power plants and supply lines.
We have two systems installed, so we can use one to power the lighting and computers in our company. It's great because we get to use about 3/4 of the electricity that's generated. The second system we use for our private household.
Salzburg is among the European pioneers in smart grid development. The aim is to use the experience gained in Küstendorf to completely overhaul the power system.
The power industry is going to experience the same sort of rapid development that the telecom industry has undergone over the past 20 years. When I think back to 1990, everyone was still sharing an analog phone line with the neighbors, and sometimes you had to wait forever to make a call. But today, we always have our smartphones with us, and we can call or access online information just about any time we want to. And like the telecom industry, revolutionary change is coming to the power industry.
Just a few bus stops away from the center of Salzburg, in the Taxham district, the future looks rosy indeed. The housing complex being built here is aptly called Rosa Zukunft, Rosy Future. The entire spectrum of renewables is being put to use. Solar power, heating pumps, hot water accumulators, a combined heat and power plant, and district heating, all coordinated using smart grid technologies. There is also an innovative mobility concept, including car sharing and electric vehicles, and a well-planned social concept, upon which the project's success hinges to a great extent.
The technological future will be significantly easier to manage than the social future. That's why the Rosy Future project has a component that we refer to as reclaiming social capital. We want to bring people back together. The architectural concept fits this idea, as does the common goal of using energy efficiently. I think it will turn out how we imagined. We've formed the right basis. The ecological and social components are in place and can be lived out in a neighborly fashion. We can only observe what happens once people move in, but the basis is there.
The pilot project has been completed. For the allocation of homes, a priority was placed on achieving a representative social mix. The Rosy Future Complex offers homes for young and old alike, including affordable and luxurious units. Life within the community appears to be harmonious. After the first year, it is also clear that the mobility concept has not caught on, but the energy concept has. The technical innovations, the use of renewable energy and smart grid technologies have all been inconspicuously integrated as a normal part of daily life. Residents can keep track of when it is cheapest for them to use electricity and have saved around 15% in energy costs during the first year. In Graz, too, the planners' aims have been fulfilled. The first housing complex in the Reininghaus district has been completed. A total of 12 residential units are connected with the office and shopping complex, together forming a surplus energy cluster. The residents are happy with their eco-houses. Undoubtedly, Graz Reininghaus will serve as a model international project for how to design a modern, energy self-sufficient urban quarter. In Vienna, the university's chemistry building is also shining in new splendor. It is the world's first plus energy high-rise. Renovation is complete and daily student life has resumed. The building's solar power system supplies it with electricity, and waste heat from the server room and elevator braking system are also being used. Countless innovations are tied to this pilot project. Lighting, computers, and telephone systems were all found to be power guzzlers and were redesigned as a result. Power consumption was cut by an astounding 93%. More than 9,300 components were optimized. The cities of tomorrow are already being designed and built today. Innovative building technologies, renewable energies, new social living concepts, and intelligent urban planning are the pillars upon which they rest.